Let's have a look at the midterm here. All right, this first term we want to find the resultant. So we want to find the resultant of the distributed load from B to C and the force at E, and we want to express that as a force couple at point A. So what we want to do is we want to find the area of the distributed load. It's a triangle, so 1/2 times the height of 380 times the base of 3 meters gets you 570 newtons. Now that's 2 meters from A, because you've got 1 meter to get to the edge, to the right angle of the triangle right there, and then the base of the triangle is 3, so it's 1 plus 1/3 of 3, it's 2. So it's at 2 meters from A. That's where the 570 newtons acts. Okay, now if we sum forces in the x direction, we'll get this force. Cosine 36 times 510 gets you 413 to the right, minus 570 minus sine 36 times 510 gets you negative 870. So that's 870 down. So to get the total resultant force, take the square root of sum of the squares. You get 963. The angles found by doing the arctangent, negative 870 over 413, gets you negative 64.6 down and to the right. Okay, if you take a moment, you've got the 570 times 2, that would be a clockwise moment. You then have cosine times 510 times 1.2, that would be this component, that would come around counterclockwise, so that's positive. And then you've got sine 36 510 times 5, that's another clockwise one, so that's negative. The sum is negative 2144 newton meters, so it's 2144 newton meters clockwise. To get the x distance, you would take the moment and divide it by the y component of force and get 2.46 meters. Okay, the next one here, we've got an equilibrium problem. We're going to have a motor that's turning this bracket against the ramp. We also have a force there at the end of that 0.5 meter part of the armature. All right, so what we're going to do here, we've got a pin joint at A, a ramp at D. We get a free body diagram there with REX and REY at A, and RD, which is at 90 minus the ramp angle, 59 degrees. All right, take a moment. You're going to take a moment about A, where 2 of the unknowns act, and then solve for RD. So when you sum moments about A, you've got 400 clockwise from the motor, the 600 times the 0.5 moment arm. Okay, now to get to RD, then we want to take that angled part of the bracket and do the trigonometry and break it up into x and y components. So cosine of 40 times 0.3 is 0.23, sine 40 times 0.3 is 0.193. So those dimensions get put in there and there. Now it's handiest to have just a simple set of dimensions from A to D. So 0.5 and 0.23 get 0.73, and 0.18 and 0.193 get 0.373. So those are the dimensions from A to D. All right, so we've got the negative 400 from the motor. We've got the 600 times 0.5 negative for this force. Then we have these forces of RD. What we have then is cosine 59 times RD. That's the x component, so that's going that way. That'll come around clockwise, so that gets a minus. X component, we get a y component of moment arm there. And then we have the y component, sine 59 times RD times 0.5 and 0.23 make 0.73. That's coming around counterclockwise, so that gets a positive. Run through the numbers, you get RD at 1614 newtons. Okay, that gets you the ramp force. Sum of Fx equals 0. We'll get you Rex to the right, minus cosine 59 times the ramp force, so Rex is 831. Sum of Fy is 0. We'll get you Ray up, 600 down, plus sine 59, 1614 up. So that'll get you Ray, negative 783, which is 783 down. Okay, so those are the reactions. The 2 reactions at A and the ramp reaction at D. Okay, the next one is a truss. Okay, I know I'm going to be working in here. I do the arctan of the 6 over the 4. That gets me the 56.31 degrees right there. Okay, want the reaction there at E. Sum of MA will get that, so the 1800 times 8 is negative, plus 12 RE coming back. RE is 1200. All right, sum of FX is 0, so REX is 0. Okay, and we don't really need RA, really not REX or even REY. We're just going to be working around joint E, so I guess I just left it at that. All right, go to joint E. That's the place to go because you have a known force and only 2 unknowns. I had a number of people try and start at C, but that just doesn't work because you've got 3 unknowns up there. It's just too many to handle, so you really do have to start at E. 1200 up in the Y direction minus the sine of the 56.3 times FCE down. Solve for FCE, it's 1442 pounds. Pushing down right, it's compression. Then you can go sum of FX is 0, so minus FDE pulling to the left is my assumption here, plus the cosine of the angle, cosine 56.3 times 1442 for the CE there. So we'll get FDE is 800 tension. You can then go up to joint C. You've got 800 down, 1442 pushing up at 56.3 degrees. FCD pushing up, sine 56.3, 1442 pushing up, 1800 pushing down. FCD then comes out to be in the direction assumed, so it's 600 in its compression. Okay, the last one, we've got a method of sections problem with a truss. Find the reactions. R sub R is 40. You get that by taking a moment about A. You got 96 times 5 meters clockwise negative plus 12 times RR. RR is 40. Sum of FY, REY up, 96 down, 40 up. REY is 56. Sum of FX is 0, that's REX. I want to find the angle for KN. Arctan of 4 over 3 is 53.13. All right, so now we want to solve for the 2 unknowns, Kn and Fi. Make a cut through Kn and just go vertically through that section of the truss. Take the right-hand side of the truss. You got 3 unknowns, Km, Kn, and Ln, but only Kn has a Y component. 40 up, and as I have it drawn there, sine of 53.13 times FKN up also. Solve for FKN, it's negative 50. I assumed it pulling, so it's actually pushing. It's in compression with 50. Make a second cut through Fi. Notice that CI is 0. If you look at joint C, you can see that that's an unloaded T. So everything else converges at D, so I take a moment about D, use the left-hand side of the truss. 56 times 2 clockwise is negative, plus 4 times whatever Fi is. Solve for Fi, it's 28 kilonewtons, positive answer, so it's tension. All right, there's a little run through the midterm there.